Hi, hello everyone. Welcome back to our favorite channel, our beloved channel, Chemistry with RK. Today I have come up with, most of the students are continuously asking me. So recently NTA has released, syllabus for 2024. So please make out a video which gives us clear clarity for the 2024 JEE attempt. Okay. So I have thought, okay, so it will help most of the students. So there are so many students who are in a bit kind of dilemma, like which concepts are included, which concepts are deleted for the next upcoming 2024 JEE. Okay, yes, I have included all the relevant information which gives us more confidence and more clarity on the syllabus JEE 2024. So just I request you to copy all the important points I am going to discuss in this video lecture. Okay, so that will help you for your smart preparation for your JEE 2024. So we have so many concepts in which there are very little concepts which are very important, which are mandatory to revise, which are mandatory to go through. Okay, so please make out all those points. You just take a pen and paper and then separate and then bifurcate all the information which I am going to give you. Okay, so please I request you to subscribe to my channel if you are new, and then don't forget to click on the bell icon to get the regular updates. Yes, we are going to come out with so many interesting and then important videos for different competitive exams which are going to come in the next year, IIT, JEE, NEET or any other state level board exams also. Okay, so let's start our video. In this video we are going to see, I'm going to give you the detailed analysis of the syllabus, and then I'm going to give you the weightage topics, and then I'm going to give the important concepts to be revised in order to get a good score in a short time. Okay, and then important formulae which are included or involved in that particular concept. Okay, yes. So if you go with the physical chemistry part, first of all, please make all the things sort out. Please try to write down the information I'm going to give separately in a book, okay, so that it will help you for your preparation. Firstly, if we move to physical chemistry part, we have some basic concepts in chemistry, so which includes matter and its nature, Dalton's atomic theory, concept of atom, concept of molecule, and then concept of element, molar mass, and laws of chemical combinations, atom, atomic mass, and then molecular mass, and then mole concept. Yes, in this particular chapter I am going to give more priority for this mole concept. So this mole concept will help you even in the other chapters also. Yes, the concept of mole we will use in almost all the physical chemistry chapters. So please give more priority for this mole concept, very important. Yes, and then percentage compositions, empirical and molecular formulas, chemical equations, and stoichiometry. Second chapter we have, that is atomic structure. So atomic structure is very important, one of the very key concepts of the physical part. Okay, and then if you observe, so in the atomic structure part we have electromagnetic radiations, and then photoelectric effect, and then hydrogen spectrum, and then Bohr's theory. This particular Bohr's theory, energy relations, and then radius relations, and then limitations of the Bohr's model. We have de Broglie dual behavior of matter, and then de Broglie relationship, Heisenberg uncertainty principle, and then quantum numbers, very important, quantum mechanics, and then quantum numbers. Yes, Schrodinger's wave equations, and then concept of atomic orbitals, one electron wave functions, and then yes, we have Schrodinger's wave equation, that is probability density, and then psi square for especially for 1s and 2s orbitals. Okay, yes, these are all included in my previous atomic structure videos. You please just go through them so that it will help you for your, I have solved so many previous JEE questions in my previous videos. Please do watch them and then try to understand. Yes, almost in the previous JEE questions also they have given questions from almost all these topics. Okay, the particular JEE 2022 June attempt if we take, they have particularly given in each session, they have given one question from any of these concepts. Like more importantly, this particular concept I give more priority, that is in the atomic structure. So that is quantum numbers. So quantum numbers, it is going to be very crucial, actually very easy, but the students generally feel very tough. So please go through my videos so that you will feel comfortable to solve these quantum number questions. Okay, and then and the significance, okay, the significance of SPDF orbitals, and then electron spin, and then spin quantum number, okay, and then rules for filling electrons. Actually we have Arbos, Pauli's and Hund's rules, right? Yes, it comes under the rules for electronic configuration, which is going to be very important. So in 2022 they have asked some questions related to these electronic configurations. They have given chromium configuration, and then some different kinds of questions we have got from this particular concept. Please go through them. And then electronic configurations, extra stability, and half filled for completely filled orbitals. Okay, so this is these are the important concepts. Actually there are no much concepts deleted from the atomic structure, which is a very important one. So they didn't delete much more concepts from this particular atomic structure. We have almost all the concepts. Okay, and then next if we move on to the chemical bonding, yes, we have Kossel and Lewis structure, and then concept of ionic and covalent bonds, and then ionic bonding, formation of ionic bond, factors affecting formation of ionic bonds, calculation of lattice energy. Yes, very important. In this lattice energy also we'll have Born-Haber cycle. Yes, by using that Born-Haber cycle we can able to calculate the lattice energy. So next, if we move to covalent bonding, concept of electronegativity. Yes, we know that concept of electronegativity, and then Fazan's rules, very important. Yes, I give more priority to this Fazan's rules, which gives us the ionic natures and all. And then next, dipole moment, VSEPR theory, one of the very important concepts in the entire chemistry, VSEPR theory. The table, VSEPR theory table, it's very important. Yes, I'm pretty much confident that you guys are going to get more number of questions related to this VSEPR theory. Normally when we have the complete syllabus, we used to get 1 or 2 questions related, it's not directly related to VSEPR theory, but now the syllabus is reduced, so the weightage for VSEPR theory will obviously increase. Okay, so keeping that point in mind, you give more priority to the VSEPR theory, and then quantum mechanical approach for the chemical bonding, VBT, valency bond theory, and then hybridizations involving SPD, and then resonance also. And then coming to the MOT, yes, this I give more priority again. After VSEPR theory, I give more priority to this molecular orbital theory. Yes, linear combination of atomic orbitals, LCAO method, and then types of molecular orbitals, bonding and anti-bonding molecular orbitals, sigma and pi bonds. We have molecular orbital electronic configurations. Yes, we have the chemical species up to 14 electrons. We follow one molecular orbital electronic configuration sequence, and the elements and the chemical species which are having more than 14 electrons are going to follow some other sequence in terms of molecular orbital electronic configuration. And then homonuclear diatomic molecules, concept of bond order, bond length, bond energy. Actually that is bond parameters. Elementary idea of metallic bonding, hydrogen bonding, and then applications. Very important. Yes, if you ask me the priority order of this particular chemical bonding chapter, so I give more priority for this VSEPR theory. Yes, that is the first priority I'm going to give. And then second priority you can have for molecular orbital theory. And the third will be, I give personally, for Fazan's rules. And then fourth one, yes, anyway here VSEPR theory itself, here we can able to understand hybridization, concept of hybridization. Okay, so when we cover VSEPR theory, and then simultaneously parallelly we can complete the hybridization. And then Fazan's rules, after that we can have hydrogen bonding. Okay, and then I give more priority for the dipole moment, that is generally represented by mu. And then we have bond parameters, Yes, almost everything, all the concepts involved in the chemical bonding are very important, but this is the priority order. So you just make out the things in this order so that it will help you. And then next we can move to coordinate covalent bond. Coordinate covalent bonds. Okay, yes, covalent bonds. So if you follow these points, it will help you. So please keep that point in mind, and then while your preparation, okay. And then next, if you move to chemical thermodynamics, yes, chemical thermodynamics. So we have fundamentals of thermodynamics. Almost we need to understand the terms. The terms in the thermodynamics are very important. Okay, the terms involved in the thermodynamics, very important. Like you are going to get questions directly from the initial part of the thermodynamics, that is system and then surrounding, extensive and intensive properties, state functions, path functions, and then entropy, and then types of process. Okay, and then after that, the important concept is first law of thermodynamics. We have that. What is first law of thermodynamics? That is delta U is equals to Q plus W. Yes, depending upon the heat absorbed or heat released, work done on the system or work done by the system, we will be getting 4 different equations. So keeping that point in mind, concept of work, heat internal energy, enthalpy, heat capacity, molar heat capacity. So that is actually heat capacity is C, molar heat capacity is a heat capacity expressed per mole. And then Hess law of constant heat summation, enthalpies of bonds, and then next dissociations, combustions, and then we have formation, atomization, sublimation, phase transitions, hydration, ionization, solution. Yes, I give according to me, the questions from thermodynamics will be covered mostly from the Gibbs free energy. The first priority I give it for Gibbs free energy, which will help you even for your preparation for chemical equilibrium, ionic equilibrium, second year mein chemical kinetics. Yes, so this particular Gibbs free energy is very important. Okay, and then again, so first I give for priority for Gibbs free energy. Okay, Gibbs free energy, and then next I give for first law of thermodynamics. First law of thermodynamics. Yes, and then after that we have something very important. Yes, actually here in the first law of thermodynamics itself, we are going to get work done in reversible, work done in irreversible. Yes, all those things will be included into this. Please keep that point in mind. Okay. And then next, the second law of thermodynamics mein humko spontaneity. Yes, that's what the Gibbs free energy and all tells us that. Okay, so delta S of universe, delta G, that is Gibbs free energy of the system, criteria for spontaneity, and then standard Gibbs free energy and equilibrium constant. Okay, so that is we generally express this equilibrium constant in terms of Gibbs free energy. The next is solutions. So here the different methods of expressing concentrations of solutions. Here they have given molality, mole fraction, only 3, and then percentages. Okay, volume and mass both. Okay, so that is volume percentage and mass percentage. But they didn't give normality here, but better you go with normality, because most of the concepts, okay, they may not give normality here, but in ionic equilibrium and chemical equilibrium, in some other chapters, even in the qualitative and quantitative analysis, we will take the help of normality. So better you don't skip normality. Okay, and for normality I have for this particular whole solutions I have given videos in my channel, so please go through them. And then next, the vapor pressure of solutions, Raoult's law. This is very important. Ideal and non-ideal solutions, vapor pressure, compositions, plots for ideal and non-ideal solutions, colligative properties, relative lowering of vapor pressure, depression of freezing point, elevation of boiling point, osmotic pressure. Yes, almost all are included into this. Okay, almost all are included into this. Here, the Henry's law they have included in the chemical equilibrium. Okay, so Henry's law, better you complete it within this chapter. Okay, and then next, almost all the concepts are covered here. So when it comes to solutions, here you first give priority for the concentration terms, and then go for the second one, that is the colligative properties. The second priority, please go for colligative properties. So if you observe the previous past papers, Okay, so they have been continuously asking these chapter questions. Okay, and then next let us move to, if you observe, the next is chemical equilibrium. From the chemical equilibrium part, they have given meaning of equilibrium is the concept of dynamic equilibrium. Yes, we have, okay, dynamic equilibrium, and then equilibria involving in physical process. Okay, so solid and liquid, liquid and gas, and then solid and gas, and then Henry's law. Yes, I have told you just now, general characteristics of equilibrium involving physical process. Okay, so that is physical equilibria, very important. And then next, chemical equilibrium, if you observe, law of chemical equilibrium, and then equilibrium constants Kc, Kp, and their significance, how to write down Kc expression, Kp expression. Yes, soon by tomorrow you are going to get the first video on this chemical equilibrium, which is very important. We can expect one question from this particular chapter in the mains. And then significance of delta G and delta G naught in the chemical equilibrium, factors affecting equilibrium concentrations, pressures. Yes, very important. These are all very important concepts. So I give more priority for the first Kc, Kp expressions, and then by using those Kc, Kp expressions, the applications of Kp and Kc, very important, and the factors affecting Kc and Kp. And then moving to the last one, that is Le-Chatelier principle. Le-Chatelier principle. This delta G and delta G naught will be included into the applications of Kc and Kp. Yeah, and the last one is Le-Chatelier principle, very important. Please don't forget to give priority for this. Okay, since this is a very small chapter, but very important and interesting concepts we have in this chapter, so don't just neglect that concept. Okay. And then next, if we move on to ionic equilibrium, so we have, yes, again you are going to get the videos belong to the ionic equilibrium soon, maybe by tomorrow or day after tomorrow. And then ionic equilibrium say weak and strong electrolytes, ionization constants, and then various concepts of acids and bases. We have Arrhenius, Bronsted-Lowry, Lewis acid base theory and all. Okay, and then ionization, yes, and their ionizations, acid base equilibria, including multi-stage ionization, and then equilibrium ionization constants, ionization of water, that is ionic product of water, and then pH scale, common ion effect, hydrolysis of salts, pH of their solutions. We have sparingly soluble salts, and then buffer solutions. Yes, almost there is nothing deleted from this chapter. Okay, because since it is a very important concept of physical chemistry, so almost all the concepts are covered. So yes, we are going to get, generally we get one question whole from physical and chemical equilibria, that is from the chemical equilibrium and then ionic equilibrium. Generally we used to get one question till now, but since the syllabus is reduced, the topics are so many chapters are deleted actually. So since they are deleted, so we can able to get one question separately from chemical equilibrium, one question separately from ionic equilibrium. Yes, you give more priority for these two. And then next, if you observe the redox reactions and then electrochemistry, redox reactions and then electrochemistry, the electronic concepts and oxidation reduction, redox reactions, oxidation number, rules for assigning oxidation number and balancing reaction. Super. So yes, these are all concepts includes in the redox reactions. And then when it moves to electrochemistry, is electrolytic and metallic conduction, conductance, and then electrolytic solutions, and then molar conductivities and their variations with concentrations, Kohlrausch law, very important. Yes, Kohlrausch law and its applications. Okay, and then electrochemical cells, which are galvanic cells we have, electrolytic cells we have, and then different types of electrodes, electrode potentials, including standard electrode potential, half cell notation, cell reactions, EMF of galvanic cell and their measurements, Nernst equation. Yes, and their applications, relationship between cell potential, Gibbs free energy, dry cell, and then fuel cells. Yes, from this particular chapter also almost all the concepts are covered. Okay, and then next let us move into the chemical kinetics, rate of chemical reactions, factors affecting rate of reactions, concentrations, temperature, and then pressure, catalyst. Yes, elementary and complex reaction, order and molecularity, and then rate law, rate constant and units. Yes, differential and integral forms of zero and first order reaction. And the characteristics, half-lives, the effect of temperature and rate of reactions, Arrhenius theory, activation energy and its calculation, collision theory, bimolecular gaseous reaction. This is all about the physical chemistry included chapters. Okay. Yeah, next let's move on to inorganic chemistry part. So we have a classification of elements and periodicity. So there are periodic properties actually. Okay. So in that there is modern periodic law and then present form of the periodic table, SPDF blocks. Yes, this particular concept is very important when it comes to the entrance point of view. Okay. And then periodic trends in properties of elements, atomic and ionic radii, and then ionization potential, electron gain enthalpy, valency, oxidation states and chemical reactivity. Okay. So you know you don't see here electronegativity, but you know better you go through that electronegativity concept also. You know, we may not get a question directly from this particular part, but the same electronegativity will be included in any of this 13th to 18th group. So it is overall electronegativity concept is important. So better you go through them. Okay. And then next, when it comes to the order of priority order, I give more priority to the ionization energy and then you know SPDF blocks and then you know the periodic properties may electron gain enthalpy be both important hai and then valency, oxidation states and chemical reactivity. And then next the entire S block is deleted. The entire S block is deleted, but you know maybe the concepts, some concepts of the S block elements we generally use it in the other chapters. Okay, but overall S block elements particularly the concepts are deleted. Okay. And the next P block, entire P block is there if you see from group 13 to 18 that is. So you know in all the chapters we are going to have the regular trends, that is the general introduction part, electronic configuration, general trends in physical and chemical properties of the elements across periods and groups, unique behavior of the first element in each group. Okay. And then compounds of each of these 13th to 18th groups are deleted. The compounds, you know, yes, if you see just the introduction part and then general properties and then physical properties and then chemical properties. So chemical properties of those particular elements, not those compounds. Okay, so no need to worry about the compounds of 13th to 18th group elements. Okay, like you have H2SO4, HNO3 from 15th group, and then we have chlorine and then what do you say, the oxo acids and all, you know, they're all you know as per the given syllabus they are all deleted. Okay, just the introduction part, electronic configuration, general trends. Anyway, this particular concept will be covered here in the periodic classification. So at least if you can able to focus more on this particular periodic classification, so it will help us in the preparation of 13th to 18th group. Okay, right. And then next if you move on to D and F block elements. So D and F block elements, yes, all the concepts of D block and F block elements are included into the syllabus. So we have transition elements, yeah, they are D block elements. If you see a general introduction, electronic configuration, occurrence, characteristic trends and in properties in the first row, transition elements, yes, physical properties, ionization energies and oxidation states, atomic radius, color. Yes, I give more priority to this particular part. So the colors of the D block or transition elements are very important. Okay, so you just go through the colors of the compounds. They may not ask the color for a particular compound, but you know the characteristic properties, by looking at their valence electrons, by looking at their unpaired electrons, we can able to have some idea about their color. Just go through them. Okay, and then catalytic behavior. The next part is catalytic behavior. Yes, this is very important, catalytic behavior. Okay, yes. And then yes, I'm writing here. So this color first one, catalytic behavior second, and then magnetic properties third, and then complex formations, and then interstitial compounds, alloys formation. Yes, you please preparation properties and uses of K2 The compounds of D block elements, you know, especially the oxoanion. This is potassium dichromate and potassium permanganate. Yes, these are included into the syllabus. So overall we can conclude that D block में से कोई भी concept को delete नहीं किया है. So just go through the chapter carefully. And then next F block elements, if you move, lanthanides and actinides, all of them are there. All the F block elements are included. So there is nothing deleted from F block particularly. So go through them carefully. Okay. And the next coordination compounds. Okay. If you observe coordination compounds, yes, and then introduction to the coordination compounds, Werner's theory, ligands, coordination number, denticity, chelation, IUPAC nomenclature of mononuclear coordination compounds, isomerism, bonding, that is valency bond theory, and then crystal field theory, colors, magnetic properties, importance of, yes, and then we don't have here, that is metal carbonyls. No, we have to include them into this biological systems. Yes, generally we include them into this particular part. Okay, so overall coordination chemistry se bhi koi like EAN calculation they didn't give particularly here, but that is a small concept, so just better you go through that. Okay, so this is all about the inorganic chemistry part. Hope you got some idea. Next let's move on to organic chemistry. So we have purification and characterization of organic compounds. So in the purification part we have crystallization, sublimation, distillation, differential extraction, and then chromatography principles. Yes, there is nothing deleted from this part. And then qualitative analysis, detection of nitrogen, sulfur, phosphorus, halogens. Okay, yeah. And then so from this particular part we can expect one question for 100%. Okay, so don't try to skip it, because there is a small concept and where we can able to get maximum question. Okay, so if you observe the next quantitative analysis, basic principle, estimation of carbon, hydrogen, it's actually done by Liebig's method, and then Zeldal's method, and then Carrier's method, and sulfur and phosphorus also, right? And then empirical formulas, molecular formulas, numericals on the numerical problems in the organic qualitative analysis. Yes, these are all simple things, like just formula based, and then just go through them. Yes, this is also included into the purification techniques itself. Okay, and then next basic concepts of basic principles and concepts of organic chemistry. So generally we'll talk about the introduction of carbon. So where we are going to talk about its allotropy, catenation, tetravalency, and then shapes of the simple molecules, hybridizations, and then classification of organic compounds based on functional groups, and then those containing halogens, oxygens, nitrogen, sulfur, yes, homologous, isomerism, structural and stereoisomerism, everything is there. So and then nomenclature, IUPAC nomenclature particularly. So yes, we have almost all the concepts from the organic chemistry. Okay. So and then if you look at covalent bond fission, homolytic and heterolytic, intermediate, reaction intermediates, carbocations, carbanions, stability of carbocations, free radicals, electrophiles, nucleophiles. And then next there is electron displacement methods, that is inductive, electromeric, resonance, hyperconjugation. Okay, yes, from this particular part again, this I give more priority for the IIT preparation or NEET preparation, because this particular concept, electronic displacement methods, we have several from which we can expect at least most of the organic chemistry questions are interlinked to this particular concepts. If you can able to understand these concepts carefully, then we can able to attack so many questions. Okay, right. And then next common types of organic reactions, substitution, addition, elimination, and rearrangement reactions. Okay, nice. And then if you observe hydrocarbons, so if we move on to hydrocarbons, so classification, we have classification, isomerism, IUPAC nomenclature, general methods of, yes, so which includes alkanes, alkenes, alkynes, and aromatic hydrocarbon, benzene. So in the alkanes we have conformation, Saha's and Newman projection. Anyway, these things will be again included into that conformational isomerism and mechanism of halogenation of alkanes. Okay, so here the preparation methods, properties and reactions are all there. And then next, geometrical isomerism of alkenes, mechanism in electrophilic addition, addition of hydrogen, halogen, water, hydrogen halides, Markovnikov and anti-Markovnikov's rule, which is also called as Karash effect. Okay, this peroxide effect is Karash effect, ozone lysis and polymerization. Yes, so these are all very important, and the names which you can see on this particular screen are very important. Okay, so you have to go through all these things. Okay, right. So if you have any kinds of doubts, I'm going to upload all these organic chemistry reactions and particular alkenes, alkanes, yes, everything. You just go through them so that it will help you for your preparation. And then alkynes, acidic character, addition of hydrogen, halogen, water and hydrogen halides, and polymerization again. So next we have aromatic hydrocarbons, so which includes benzene. So if you look at nomenclature, benzene, structure, aromaticity, mechanism of electrophilic substitution, halogenation, nitration, sulfonation, Friedel-Crafts alkylation, acylation, directive influence of groups. Yes, and this particular part of this directive influence of functional groups in monosubstituted benzene, so that is going to be crucial for your second year organic chemistry. Okay, so this particular part is very important. Okay, yes, I am going to upload the separate video on this, so just go through that. And then next let us move into second year organic. This is actually second year organic chemistry. Yeah, and then organic compounds containing halogens, which are alkyl halides and aryl halides. If you observe, general methods of preparation, properties, reaction, nature of CX bond, mechanisms and dye substitution reactions. Uses, environmental effects of chloroform, iodoform, freons, DDT, dichloro, dimethyl, trichloroethane. Yes, it is actually a pesticide, insecticide. So I am going to give another video on this DDT and then all this reaction involving halogens, okay, alkyl halides and aryl halides. Organic compounds containing oxygens, which includes alcohols, phenols and ethers. Okay, so in Tinoka, preparation methods, properties are all important. Just have a look into that. And then next alcohols mein humko identification of primary, secondary and tertiary alcohols. Yes, it is very easy. And then phenols, iska preparations and properties are already there. They mentioned in the previous line. So acidic nature of phenols, electrophilic substitution, halogenation, nitration, sulfonation, Riemann-Tiemann reaction, very important. This is actually conversion of phenol to salicylaldehyde, okay, in which the intermediate is dichlorocarbene. Very important reaction. This is Riemann-Tiemann reaction. And then ethers may structure, and then preparation and properties are also there. And then next aldehydes and ketones, nature of carbonyl compounds, nucleophilic addition, and then C double bond O, and then relative reactivities of aldehydes and ketones, important reactions such as nucleophilic addition reactions, addition of HCN, NH3 derivatives, ammonia derivatives. Okay, we are going to have carbazide, semi-carbazide and all. Okay, right. And then Grignard reagent, and then oxidation, reduction, Wolff-Kishner, Clemmensen reductions. And then acidity of aldyl condensation, Cannizzaro reaction, haloform reaction, yes, very important, which includes Fehling's and Tollens test here. Okay, and then next, if you observe, next moving on to carboxylic acids. Carboxylic acids may acidic strength and factors affecting it, where we are going to talk about where there is an important concept called as ortho effect. Okay. And then next, if we move on to compounds containing nitrogen, okay, organic compounds containing nitrogen. So where we are going to have general methods of preparation, properties and reactions and uses, amines, nomenclature, classification, structure, basic character. This is important, and then identification of primary, secondary and tertiary amines and their basic characters, right? And here we are going to have in solution state, in aqueous state separately, in gaseous state separately. Just go through that. That is the key point there. And diazonium salts, and here we have a benzene diazonium chloride to chlorobenzene, that is halobenzene conversion, that is Sandmeyer and Detterman reaction. We have fluorobenzene preparation also, which is called as Schiemann reaction. Just go through that carefully, okay? And then next, let's move on to biomolecules. So if you observe general introduction of biomolecules, carbohydrates are there, classification, aldoses, ketoses, monosaccharides, glucose and fructose particularly, constrained monosaccharides, oligosaccharides, sucrose, lactose and maltose. Their structures also, their pyranostructure, furanostructures and proteins are also there, amino acids, peptide bond, polypeptides, proteins structures, primary, secondary, tertiary, quaternary structures, and then denaturation of proteins and enzymes. Very important. All these are very important. And then vitamins, classification and functions of vitamins. Okay. And then nucleic acids, we have a chemical constitution of DNA and RNA. Yes, nucleic acids, we have deoxyribonucleic acid and then ribonucleic acid. And then biological functions of nucleic acids, we have hormones. Yes, general introduction. Almost all the concepts from the biomolecules are covered in this particular syllabus. Okay. And if we move on to the next principles related to practical organic chemistry. Okay. So detection of extra elements, nitrogen, sulfur, already we have done in qualitative analysis. And then organic compounds, and then detection of following functional groups. Yes, hydroxyl, that is alcoholic and phenolic functional groups, carbonyl, that is aldehydes and ketones, carboxyl, amino groups. All these are the practical organic chemistry. And then chemistry involved in the preparation of the following. Yes, more salt and potash alum. Yes, these are all included into the practical organic chemistry. And then organic compounds, acetanilide, para, nitroacetanilide, aniline and iodoform reaction. Generally alpha methyl containing groups will undergo iodoform reaction. I am going to give you a separate session on this iodoform. Just follow that. Okay. And then chemistry involved in the trigonometric analysis, acids, bases, and then use of indicators, oxalic acid versus potassium permanganate, more salt versus potassium permanganate. These are all laboratory related things. And then chemical principles involved in the qualitative salt analysis. So we have to we have to know about all these cations and anions. This particular preparation will be in the labs. Okay, so labs mein jo hum experiments karega, like that will help you for the preparation of this particular concepts. And then chemical principles involved in the following experiments. And then enthalpy of solution of that is CuSO4, and then enthalpy of neutralization versus strong and strong acid versus strong base, and then preparation of lyophilic and lyophobic salts, and then kinetic studies. Yes, all these are for your practicals. You know, no need to worry. Actually, we can expect one question in the mains from this particular part. Okay. Yes, this is all about the syllabus. And then yes, the important concepts also I have discussed, where to focus more, where to just where to give less time, where to focus more. And then please you try to take advantage of this particular video, and then try to write down your things separately, and then it will help you for your IIT preparation. Thank you so much. This is all about the syllabus for the 2024 JEE mains and upcoming exams. So please, I request you to subscribe to my channel if you are new, and then don't forget to click on the bell icon to get the regular updates. Yes, for the next 2 months, you are going to get some number of videos on the this particular order only. I am going to follow the same order, like on the priority basis. So please do watch my channel regularly. It will help you a lot. Thank you so much for your patience. Thank you for watching the video. See you soon.